Parameterization in vector. That is a new topic in calculus and it is required in calculus because we need algebra in calculus. We need algebra in calculus. So calculus is cannot exist without algebra. But we have been seeing, we have had seen that vector is something that is not algebra. Okay, so algebra is a kind of mathematics which is something like if we have independent and dependent component and they are related through the rate of change. That is the kind of algebra. Like if I say there is an independent component x and there is dependent component y, then y equal to mx means that is the equation of the line where m is dy by dx. That is the rate of change that we see in y with respect to unit change in x. So y equal to dy by dx or delta y by delta x into x. That is the equation of the line of the in algebraic form. Okay, so this is power of algebra. Means we have independent component and dependent component, and they are related through the slope. They are related through the gradient. They are related through the differentiation. They are related through the derivative. So, or they are related through the dy by dx. So, if I have a surface equation z is dependent and xy is independent, then z equal to dy by dz by dx into x plus dz by dy into y. So that is the equation of surface. Y equal to dy by dx is equation of the line. So if we see closely, then dependent variable that is z or y is dependent upon the independent variable through the rate of change. That is the base of algebra. Either we go with the line, we go with the surface, or we go with the volume that is 3D, or we go with the n number of the dimensions. So that is the concept of the algebraic calculus. But it has pitfall. It has, I would say, caveat, or it has some kind of uh, ditches. So the concept is that algebra lacks in direction. You have to do so many things to get the direction, or lacks in magnitude. So these are the things that algebra lacks, where the vector is very powerful as far as direction is concerned, very powerful as far as magnitude is concerned. Okay, so now I can put vectors power, direction power, and magnitude power inside the algebra or algebraic power inside the vector. This is what we are saying. So algebra bend and algebra we will push inside the vector. So vector will go along. This is a new arena in the research that you push algebra inside the vector where vector itself has kind of, you can say that orthogonal component. If I have a vector called 2i plus 3j plus 3k, then there are many ways that we see this vector. One way is its x component is 2, y component is 3, and z component is 4, 2i plus 3j plus 4k. Now, yeah, I can consider it as position vector also, where there is a line from origin 0, 0, 0, 2, 3, 4. If I draw a line, then it becomes a positive position vector, and that is 2i plus 3j plus 4k. Or I have three separate vectors. One is going in positive x direction from negative x axis, and one is going in positive y direction, one is going in positive z direction. One is 2y, one is 3j and 4k. If they meet at origin, all three vectors, and they combine, where they would go? They would go in a direction that is called 2i plus 3j plus 4k, or direction. If I connect origin to 2, 3, 4 point in whatever direction I am seeing, then in that direction. So that is a concept of vector. So I have the direction. And what is the kind of magnitude of this vector? A vector is an energy which has a direction and which has magnitude. If I calculate the magnitude separately, then 2, 3, and 4. Since they are orthogonal to each other, we cannot add them the way we add. So it is not 2 plus 3 plus 4 because they are orthogonal to each other. They are not related to each other. In that sense, then we can say 2 square plus 3 square plus 4 square square. That is the magnitude. So this is the concept that we have in vector already. And then if you want 2, 3, 4, 2i plus 3j plus 4k as a vector, now if I want it in a line equation, or if it is 3D, if I want it in surface equation. Surface equation means if I have xy plane, if I have xy plane, in the xy plane, if I have several points as x comma y, if I have several points as if I have several points as x comma y, then for each x comma y, what is the vertical? If I connect all the vertical, I have x comma y, I have x comma y, I have x comma y. Okay, I have so many x comma y. For each x comma y, for each x comma y, I have z value. If I connect all the z values, okay, and then draw it, it is a surface. In 2D, if I have x value, and for each x value, I have y value. If I connect all the y value, it becomes a line. If I have x value, xy plane, for each xy I have a z value. If I connect all the z value, it is a curve, but it is a surface. Okay. Now that is the situation. If I take all along, then it becomes a volume. So like in kind of 3D, we have many points. If I'm drawing a 3D with x, y, z, then I have many points here and there. So those are called kind of vertices. Whereas if I connect few lines and then draw lines, it is called a wireframe, vertices, and then wireframe. If I connect the wireframes, it becomes a surface, and then if I cut it somewhere with one plane, it becomes a cross section. If I cut along z axis, it becomes a contour. Or anyway, if I draw everything as an algebraic equation, then anyway we have the graph. So this is a kind of little bit about the 3D. Now we have algebraic equation. So if I want to have the algebraic, like if we had vector 2i plus 3j plus 4k, 2i plus 3j plus 4k, that is the vector. Then if I want it in kind of 3D, in algebraic equation, then z equal to m1x plus m2y or mx plus ny, where m is dz by dx and n is dz by dy. So if I see the vector 2i plus 3j plus 4k, then if x varies 2, then z varies 4. 4 by 2 is dz by dx, where dz by dy is 4 by 3. So z equal to 4 by 2 x plus 4 by 3 y. Then z equal to, let it like this. So z equal to 4 by 2 x plus 4 by 3 y. This is the equation of surface in algebra, where immediately I cannot say if someone gets this formula 4 by 2x plus 4 by 3y minus z equal to 0, and if I say what is the direction of the surface, probably he will use his brain. But if I say that there is a vector called 2y plus 3j plus 4k, then what is the direction? Immediately from origin, he will think about the point and he would draw a line saying this is the direction. What is the magnitude of this? 2 square plus 3 square plus 4 square by square root. Okay, so vector in some sense it is very powerful. Now, how we can push? Now, but if you see the algebraic equation, in one go, we have all three. 4 by 2 x plus 4 by 3 y minus z. In one go, we have all three independent components. Whereas vector, all three components are separate. If I say 2i plus 3j plus 4k, x component is 2, y component is 3 and z component is 4. Now pushing again x, y, z everywhere and then doing the calculus, it is kind of something that is difficult and kind of tedious to maintain, because anyway we have x, y, z component. Whereas in algebra it is nothing like that. We can club together all the x, y, z. We can start there differentiating it with respect to x, with respect to y, with respect to z, keeping other two as constant. Okay, but here since we have x, y, z components separately, we can differentiate it separately. If that is the case, then what is meaning of keeping others constant? Anyway, for one component, we are trying the differentiation. If that is the case, then we cannot afford three independent variables. In algebra, we had two independent variables. If I say z equal to mx plus ny, then two independent variables. But here, two independent variable is also not possible, because every variable has its own component. So to have that, we will have one independent. Now we are pushing algebra inside the vector. That is the story. So we will have one independent component. We call it T. T. So T is the independent component that is spread across X component, Y component, and Z component. If that is the case, then T is independent, then X, Y, Z are dependent on them. If this is T and this is X, Y, Z, they are dependent on them. If I see the algebra, then these are X, Y, and Z is dependent upon them. But here, all three are dependent upon T. So, if it is 2i plus 3j plus 4k, then it is, if I consider X as 2t, 2t, then y is 3t and z is 40. So 2ti plus 3tj plus 40k, we introduce algebra now. Algebra means there is a function over independent variable. That is algebra. This is parameterization, because if I say a function that is fx, function that is fx, then f is a function where parameter is x. This is a Python function we can consider. So in Python function, if there is a parameter and x is the parameter, if you push x inside the function, then function do all the calculation and it would return the result. Same function here also. So now I can, if I say 2t plus 2ti plus 3tj plus 4tk, then 2t is ft, function over t, and then 3t is gt, and then 4t is ht. So there are three algebraic functions we brought in here, where independent component is same, that is t. So ft, gt, ht, 2t, 3t, 4t, 2ti plus 3tj plus 40k. Now algebra we have put inside the vector where the three components x, y, z are 2t, 3t, 4t, where 2t we kind of address as function over t, parameterization, where parameter is t, then ft, gt, and ht, where ht is 40. So now we have pushed algebra inside the vector, but independent component we kept it as one. In vector field later on, we will see a vector field. Okay, so there later on we will see other more independent component, but there is a limitation and there are scenarios. So at the end we will come back to, we will grab those things to variation of T1. So T is the master. So one independent component, three dependent component. Whereas in calculus, algebra, we had one independent component, one dependent component, y equal to mx. Two independent component, one dependent component, z equal to mx plus ny. Three independent component and one dependent component, fxyz equal to m1x plus m2y plus m3z, where m now fxy z, the function over xyz, if I consider this a density function d, then dd by dx, dd by dy, and dd by dz, that is m1, m2, m3. Okay, now that is the scenario. Anyway, we have vector ready, that is 2ti plus 3tj plus 40k, where we have introduced the algebra. Or I can say t outside in the braces 2i plus 3j plus 4k, whatever is kind of easy. So that is the algebra inside the vector. So this I can call it as a position vector. If I have a point called 2 3j 2 3 4, then I call it is a position vector, that is 2i plus 3j plus 4k, because the kind of the bottom, okay, if I have a vector, then there is a top and there is a bottom. If I consider that way, okay, the other side, the downside, that is the origin. So it is a position vector. If this is the kind of if 2i plus 3j plus 4k is a position vector, then I can call it as r. R, on top of it there is a arrow. R, on top there is arrow. So this is a vector. Vector is 2i plus 3j plus 4k. But if I say that 2ti plus 3tj plus 4tk, now R becomes a vector that is a kind of dependent upon t. So I can call R braces inside that T and arrow on top. Now R is a kind of a vector, but it is a parameterized vector. It is a parameterized vector. If this is a parameterized vector, then R braces T, the way we had in the vector ft, gt and ht. Now the full vector, earlier it was r, on top of it arrow, r is a vector. Now r is a parameterized vector. It has a parameter t. It's a kind of a function. Then it is r braces t and then vector. So this is the new notation. Now what is the other strength? So one strength of the kind of algebra is independent and dependent component relationship. That is the algebra. But what is the other power of algebra? If I have a line, and this is 0 0 0 and this is 2 3 4, then this is a line that passes through the origin. But if I shift this line up 0 0 2, that is along the z axis vertical, I shifted it up, then equation of the line would change. Or I can say the line is shifted up in a way that it make intersection on z-axis at 2. So 0 0 2. What is the equation of the line? If I say z equal to mx plus ny, then it is z minus 2 equal to mx plus ny. Okay. Now, if I say it is passing through either I can say it make intersection at 0 0 2, or I can say that I provide an offset of 2 or shifted 2 along the z axis, or I can say the line was passing through origin earlier. Now it is passing through 0 0 2. If it is passing through 0 0 2, then equation is z minus 2 equal to m x minus 0 and y minus 0. If that is the case, then any line which is passing through origin, the equation is z equal to m1 x plus m2 y, or mx plus ny. But if it is passing through a line, a point that is x0, y0 and z0, then equation is z minus z0 equal to m1 braces x minus x0 plus m2 braces y minus y0. So this is algebra. So algebra is very powerful when you see independent dependent relationship, and through especially through the derivative, and then placing the surface or line shifting anywhere else. Passing through this point, you can just say z minus z0 equal to m1 x minus x0 plus m2 y minus y0. Okay, but what in vector? If I have a vector that is passing from 0 0 0 and 2 3 4, then it is 2 minus 0, 3 minus 0, 4 minus 0, then 2i plus 3j plus 4k, that is called position vector. But if I make this shift up, now it is passing through 0 0 2 and 2 3 6, and if I draw the line and try to get the vector equation, then it is again 2 minus 0, 3 minus 0 and 6 minus 2, again 2i plus 3j plus 4k. So that is called displacement vector. When the any of the point, none of the point is origin in the vector, then it is called displaced, it is displaced. Whereas position vector, where it is passing through the origin. So all displacement vector are position vector only. Means if I have one point x0, y0, z0, and there is another point x1, y1, z1 where none of them is origin, then if I say that I want the displacement vector, then it is x1 minus x0, that is the x component, y1 minus y0, and z1 minus z0, that is the z component. So this is the kind of, it looks like a displacement vector, but it will come as a position vector. Then what is the fundamental, that if I have a vector that is passing through the origin and point 2, 3, 4, I can shift it along the z-axis to the point 0, 0, 2. That is the idea. Now, in algebra, in vector, it is not possible. It is absolutely not possible. But in parametric vector, algebraic vector, okay, it is possible. So if I say my algebraic vector equation is 2t plus 3t, 2ti plus 3tj plus 4tk, okay, this is my vector v or vector r, then, then, okay, can I add another vector to it called 0i plus 0j plus 0k? These things are not available in any of the book. You can search. So my 2ti plus 3tj plus 40k is now 0i plus 0j plus 0k braces I can put plus 2ti braces 2ti plus 3tj plus 40k. There are two vectors. I added zero vector. Zero is the most important invention, discovery, whatever happened in mathematics. It looks like zero. Like zero has kind of no import. It doesn't do anything when it is added. But in subtraction, it has kind of effect. Like if I say zero, if I have 4, if I say 0 minus 4, it becomes minus 4. In multiplication and division also, 0 changes. But in addition, 0 does not do anything. 0 this side or that side, it does not change anything. So if I say I have a 0 vector 0i plus 0j plus 0k and plus 2ti plus 3tj plus 40k, it is same as 2ti plus 3tk plus 40j. If I have a kind of parametric function, consider 2ti plus 3tj plus 40k, and t I consider independent variable as time, and if I say at time equal to 0, then poof, there is nothing. Or t in the braces 2i plus 3j plus 4k, if that is the vector and I multiply by t and time equal t equal to 0, what is the position of the vector? Then nothing, it is null. Nothing. But if I add 0 vector, 0, these explanations are not available anymore. Okay, so we will file disclosure per video. Anyway, so 2i plus 3j, 0i plus 0j plus 0k, if I add to a vector t and then 2i plus 3j plus 4k, at t equal to 0, anyway I have the origin. So it passes through the origin. T equal to 1, then 2i plus 3j plus 4k. This is what we wanted. So the equation what we had 2ti plus 3tj plus 40k. Now if I add 0i plus 0j plus 0k, that is the 0 vector, it makes sense also when t equal to 0. Now anyway, so it makes sense in other aspect also. So if I have a vector 2ti plus 3tj plus 40k, and if I add 0i plus 0j plus 0k, anyone would say it looks like it passes through origin, because first component is 0i plus 0j plus 0k, looks like it is passing through origin, because if t equal to 0, it passes through origin. Now I want it to pass through 0, 0, 2. Let's change it to 0, 0, 2. Now it is 0i plus 0j plus 2k plus t 2i plus 3j plus 4k. If that is true, when t equal to 0, then our vector is at 0, 0, 2. If t equal to 1, then our vector is at 2i plus 3j plus 6k. Means if this is the origin of this vector, if this point is origin of the vector and vector shifted up, then this becomes 0, 0, 2. Then this also shifted up and it becomes 3, 2, 3 and 6. So we can do displacement now in vector also with the parameterization. Power of algebra we are inserting inside the vector, that is parameterization. Now equation of the new vector is 2k plus 2ti plus 3tj plus 4tk, or I can say 2ti plus 3tj plus in braces 2 plus 4t braces close k. Now z component is 2 plus 40 and xy is 2i and 3j. If I say that my vector is passing through a point called x0, y0 and z0, then it is x0 plus 2 is the x component I, y0 plus 2 y component j, and z0 plus, okay, so x0, y0 and z0, x0 plus 2i, 2ti, y0 plus 3tj and z0 plus 40k. Okay, so that is the scenario that we are getting as far as displacement vector is concerned, where a vector shifted its position. So this is like we have now in a nut, okay, we are getting the universe. So that is the concept now, parameterization of vector. So we are getting a new vector that is x0 2t, y0 3t and z0 4t, when it used to be a position vector passing through 2 3 4 point, and then we did the parameterization and we introduced t. Then after that, that line is passing through x0 y0 z0. Okay, so this is the concept of, now we have full-fledged algebraic equation inside the vector. x0 plus 2t I, x component is x0 plus 2t, y0 plus 3t j, and z0 plus 4t k. Okay, so this is kind of a new research area, and we'll see vector field and those things, then you will really feel that this is a new research area. Now let's proceed and we'll kind of do some kind of example. Then we'll proceed in velocity and acceleration. At least we'll cover the velocity part. Anyway, now suppose that what can be the example. So yeah, I have in YZ plane, there is a YZ plane. If I say YZ plane, then in the YZ plane exists for each x. Okay, if x is constant, then there is a YZ plane. If y is constant, at for each y we have XZ plane. If z is constant, then we have xy plane at each z. So if I have xy plane and then there is a circle with radius r, or someone is rotating in a circular fashion, okay? If someone is rotating in a circular fashion, so this is a circle, this is a circle, and if this is a circle, then this is center. If this is the center, then this is radius. If this is radius, the guy is rotating in radius in clockwise direction in YZ plane. If that is true, then radius is r. Then what is the equation of the circle? Okay. Now, if I say that if I consider the y direction, if I consider the y direction and if I consider the z direction, okay, then equation of circle typically is y square plus z square equal to 0. I mean y square plus z square equal to r square if it is in yz, if it is in yz plane. But if I see the radian fashion, then in parameterization it would come as r cos t, where t we can consider anything like angle. So r cos t I vector plus minus, because it is going in clockwise direction. If it is anti-clockwise direction, then plus. So r cos t I plus, I'm sorry, r cos t I minus r sin t, r cos t j. Now it is in yz plane. So r cos t j minus r sin t k. Okay, ith component is 0. So 0 I plus r cos t j minus r sin t k. Okay, so this is the equation of the circle person is rotating in the yz plane, where t is in angle and radian. If t is 0, then it is along the y-axis, because z sine 0 is 0. But if t is 90 degree pi by 2, then it is only z-axis exists and y-axis do not exist. So this is a kind of parameterization circle equation in kind of vector form. So 0I plus r cos t. So now the y component is in function of t. R cos t j minus r sin t k. Okay. So this is a circle in kind of where the x component is 0. Where the x is 0. So yz plane exists at particular x. Okay, if I shift it here and there, then equation would change. If I shift it to 2, this is at origin, means this is x is 0. If I shift it here and x is 2, x is 0, x is 2, then it will become 2I plus, then we have not shifted anywhere in yz plane. Then as per whatever we have talked now, then x0, y0, z0. So x0 is 2, y0 and z0 are 0, 0. So 2I plus r cos t minus r cos t j minus r sin t k. Okay, if this is the circle and its center is here. If this is circle and this is the center, and we rotated in yz plane where this is x axis and this is y axis, this is z axis, we shifted it along x axis to whatever we shift it somewhere that is 1, 2 and 3. Now origin is or 0. Now origin is 1, 2 and 3. What is the equation? Then first vector, you remember, that is the kind of shifting vector. And then next vector is the parametric vector. Then we have 1I plus 2j plus 3k plus r sin t j minus r cos t j minus r sin t k. Then it would come as, okay, 1, 2, 3 means I plus 2 plus r cos t in braces j plus 3 minus r sin t in braces k. So now we have parametric equation and we shifted it also. So this is the kind of a power of vector. Now, okay, let's forget the shifting. Let's consider that our circle is in xy plane and this is x and this is y. This is x and this is y. Okay. So if that is the case, then if I say the equation of the line, if the circle is r cos t I plus r sin t j, where it is someone is rotating along the anti-clockwise, r cos t I plus r sin t j. Okay, so if that is the scenario, now if I take any point here, if I take along x-axis, if I take it is origin, and if I go along x-axis, and this is r0 because r is the radius, then our vector is perpendicular. Can you see? If this is the surface, if this is the line of the circle, then our radius from 0 to r, it is crossing perpendicular. If I take angle t as 90 degree, then r cos t is 0, whereas r sin t is 1, that is r. So at that position, it is going like this. From 0 origin, it is going in y direction and it is crossing like this. This is the vector. So vector are nothing but if I have a line, if I have a circle, then at each point, if I take angle as 45 degree, okay, then we are here and this is r. If we are here, then r cos t I plus r sin t j. Now we have cos t cos 45 degree and sin t 45 degree. They are equal and both exist. In that case, then if we see, then the vector would pass like this. So again perpendicular to the line. So everywhere vector is perpendicular to the line. That is the, so nicely, right? If I say r cos t I plus r sin t I, then what is the magnitude? R square cos square t plus r square sin square t, that will come as square root, that will come as r only. So magnitude is the radius. Okay, at any point, any angle, at any angle t, can you tell me what is the vector direction? Vector direction, if you see at any angle t, okay, then the direction has, if I say position vector which is 0 0 and to a point, if I have a point and I have another point 0 0, and if I draw a line, that is the direction, then the point other than 0 is r cos t, that is x component, and r sin t is the y component. If I have that point from origin, if I draw, that is the direction. Because x component, y component, and z component are inbuilt inside the vector. So direction and magnitude so quickly. Anyway, now we will find the velocity. So easy, right? If I say that I have kind of angle, so if I say r cos t, r cos t. Now instead of, suppose that there is a guy, okay, and he is kind of, this is xy plane, okay. Earlier this is xy plane, this is x and y. Now I rotate it like this. Now this is x and this is y. If this is x and this is y, then a guy is rotating like this. There are kind of, you see equipment, or you see the big toy that kid they play. So he is rotating like this. He is rotating. He sat on some chair and he is rotating like this. If he's rotating like this, then if I talk about the position at any time, position at any time. So now t is not angle, rather t is time. So if that is the case, then I can have equation like r cos pi t. Suppose the r cos theta t I plus r sin theta t j, where theta are angular speed. Okay. Now if I say when t equal to 0, then he is at horizontal in x direction, because sine equation is r cos theta t I is a vector, plus r sin theta t j. So that is in xy plane. When t equal to 0, at time t0, he is on x axis. When time is kind of pi by 2, okay, when time is, suppose time is pi, time is I'm sorry, okay, now time is 1, time is 0, now time is 1. When time is 1, then he in 1 second 1 second he has rotated pi. So he has made kind of pi kind of rotation. If that is the case, then if I say r cos theta t I plus r sin theta t t, when t equal to 1, then the kind of the distance, so the t, theta t, r cos theta t, the theta t is a kind of net distance he is traveling. Then equation would become r cos pi t, where theta is the speed and t is the time. Speed is nothing but distance by time. T, if I cut it down, the distance. Okay. So if I say that r cos theta t I plus r sin theta t j, and t equal to, when t equal to 1, he is rotating like this. When 0, at time equal to 0, then he is here, and when time equal in 1 second, he is going, he is rotating pi degree. Then in that case, theta into t, when t equal to 1, then it theta into t becomes pi, because he is rotating pi kilometer per second. So theta is speed, then pi meter per second into t 1, then pi. So his equation is r cos pi t plus r sin pi t, where t is the time. So when t equal to 0, then he is along the x-axis. When t equal to 1, then again he is along axis in minus direction. So when t equal to 1, then equation turns to r cos pi plus r sin pi. One is I and one is j. Okay. Now this is the equation of kind of a, a small child who is rotating in an arc where his speed is pi radian per second. Pi radian per second. So 1 second if he is at 0, then next second he is at pi. Next second he is again coming back to 0. If that is the case, then equation is r cos pi t I plus r sine pi t j. When t equal to 0, t equal to 1, t equal to 2. If t equal to 2, then it becomes the angle is 2 pi because he came back to the origin. So this is the equation of a guy who is rotating in an arc and it is a scenario. Now if I see the position vector, then if it is rotating and this is xy plane, then it is perpendicular. This is what we have seen. Now, what is the velocity at any time t? Then x component of the velocity and y component of it. So simple because independent component is only one, that is t. Earlier independent component were so many and then partial derivative existed. Chain rule, partial derivative, orthogonal component, nothing is required. So x component, if it is r cos pi t, then it becomes like minus r sine pi t. And r sine pi t, it becomes pi r cos t. So if I have an equation of a circle as r cos pi t I plus r sine pi t j, then if I calculate this is r, then dr by dt, that is the velocity. If dr by dt is velocity, then for each component, because each components are orthogonal to each other, they are not dependent upon each other. So each component we will calculate the derivative. So x component was r cos pi t. Now it becomes minus r sine pi t. Y component is r sine pi t. It becomes r cos pi t. R pi r cos pi t. Here minus pi r sine pi t. Okay. Now equation of the position vector is r cos pi t I plus r sine pi t j, where an equation of the velocity vector is minus pi r cos pi t plus pi r, okay, minus pi r sine pi t plus pi r cos pi t. Okay, can I do dot product of these two vectors? If I do the dot product of these two vectors, then it would be like r square minus r square pi square cos pi t sine pi t, that is x component, and y component is pi square r square sine pi t cos pi. Now if I add these two, it becomes 0. This proves that the kind of the position vector what we had, if this is the circle and these are the position vectors, then the velocity vector is at 90 degrees because dot product is 0. These are the kind of extremes that we are seeing vectors because position, direction, and magnitude, everything is inbuilt in the vector. No need to put hybrid. Can you see how easy it is to calculate the velocity? Okay. Now velocity dot position vector r is 0. Then if this is center, if this is the position vector and velocity vector is perpendicular to it, then velocity vector is this. If this is position vector, then velocity vector is perpendicular to this. So velocity vector is nothing but tangent to the arc at any point, at any angle, okay, at any angle pi t, where t is the time and pi is the velocity, that at any angle pi t, so if t equal to point t equal to 0.25, that is pi by 4. So it is, if this is x-axis, then we are here. So if we are here, then this is the position vector. Then tangent, this is the velocity vector. Position vector and velocity vector. So velocity vector at any point, since the position vector at any point is perpendicular to the arc, then velocity vector is 90 degree to the position vector. So it is tangent over there. So easy to find, right? Or if I try to find the velocity vector direction, then minus pi r sine pi ti plus pi r cos pi tj. Now if I calculate the position vector with this value, no one stops me to find that it is tangent. No need to do dot product. So whatever the x component, that is minus pi r sine pi t, and whatever the y component pi r cos pi t, for each t, if I get the x value and a y value and put a position and through origin, if I draw the line, then it will be tangential everywhere. Now, let's see what is acceleration. So, acceleration is again one more derivative that we are calculating. So, certainly if I do the one more derivative, then it will be perpendicular to the velocity. So, if I say minus pi r sine pi t, the I component, now it is minus pi square r cos pi t, and that side is that side is minus minus pi square, there also minus pi square r sine pi t, minus pi square r cos pi t minus pi square r sine pi t. If I take out minus pi square, okay, minus pi square, then inside it becomes r cos pi t I plus r sine pi t plus j. It is as good as a position vector. In position vector, if I multiply minus pi square, then it becomes the acceleration vector. So it looks like minus means reverse direction. Minus means reverse. If this is position vector, perpendicular to this is velocity vector, then perpendicular to this is the acceleration vector. If this is position vector, then if position vector is this, then acceleration vector is negative to it with one amplitude added, that is pi square. If this is position vector, then this is acceleration vector in same direction opposite. If this is position vector, then this is velocity vector 90 degree to it. Again 90 degree to it, this is the acceleration vector. So these are the concepts when we are taking the arc. If I have an arc, then position vector, velocity vector, and acceleration vector all are perpendicular to each other. So enemy's enemy is friend. Enemy's enemy is friend. So if position vector has enemy called velocity at 90 degree, then enemy's enemy, that is acceleration, is friend. Only thing is that direction is reverse. So now we have kind of so nice velocity vector, so nice position vector and acceleration. But this story is only for the arc. If I take a straight line, if something is if energy is going in this direction, energy is going in this direction, then if I calculate the velocity, then dr by dt, velocity will be also in this direction. If I calculate the acceleration, this is not deceleration, acceleration, then acceleration is along this direction only. So if it is a straight line, if it is a straight line, okay, like if I say that t square, the equation of the vector rt is t square 2i plus 3j plus 4k, then velocity vector will be 2t into 2i plus 3j plus 4k. So they are in the same direction. Acceleration will also be that 2 and then 2i plus 3. So if it is a straight line, getting it right? So if I say I have a position vector 2i plus 3j plus 4k, and then I convert it to parameterization where t is t square or t to the power 3 or t to the power 3 plus t, in a braces t to the power 3 plus t, okay, and bracket close, and in other vector, other braces, we have the vector 2i plus 3j plus 4k. Now for each change in the t, then this becomes scalar, so this is a straight line. If that is the case, then the velocity is t, if it is t to the power 3 by t plus t, then it is 3t to t square plus 1, and acceleration is 6t, whatever. If I have a straight line and it is parameterized, then velocity is in same direction, acceleration is the same direction. But if I have arc kind of like circle or ellipse or any arc, then velocity is tangent to the position vector, and then acceleration is it just opposite to the position vector, but it share the direction. Okay, there are many things that we should talk now, calculating the parameter length of the curve, and then a few examples we do, and then we would kind of proceed to much awaited vector field. So that we will see.